Hello, everyone. Thanks for coming. My name is Bora. I'm the product manager for advanced analytics at Tableau. I used to be the product manager for calculations team as well, so I worked on this project, wrote the specification for it. So if you have troubles, you can get your anger on me after this session. So there are two types of sessions about LODs in this conference. Some of them will give you a really complex business problem that they're trying to solve and show you an example. And then hopefully you understand them later by kind of going through it, which is a good way of showing the value of the feature. But I wanted to take a different approach with this one and instead walk you through how it works. Like, take a look under the hood so you can understand the pieces, and then you could build whatever you want with it as opposed to working backwards from an example. So first, we need to start talking about what LOD is. So LOD is short for level of detail. And your data has level of detail from the moment it's collected. If you're collecting sensor data, it could be per second. That's your granularity of the data. If you have data about customers, each customer is a row of data with the age, gender, education, etc. Then the granularity of the data is the customer. And here's an example from our Superstore database where the granularity of the data is essentially an item in an order. Right? Well, of course, as you aggregate the data, its level of detail changes. You can go from order to sales per year or region. For example, in this example, we have 4 regions. Level of detail is region. For each region, you get a bar showing sum of sales for that region. So level of detail for this viz is region. In this viz, you have 12 marks because we have 2 dimensions, category and region. And each mark is a combination of the 2. For example, furniture east, furniture west, office supplies east, west, north, etc. And you see the values for sum of sales and sum of profit for each of those combinations. So we talked about having dimensions like category and segment in certain shelves and how they impact the level of detail of your view. So not all the shelves are created equal, so some shelves have impact on level of detail, some don't. Here you're seeing the shelves highlighted in green. If you drag any dimensions into any of these shelves, they will change the level of detail of your view. So I highlighted pages using dashed lines because it behaves a little differently. Even though it changed the level of detail of the view, like most other shelves, you may not see a difference in the number of marks that are in the view, because it will also filter out the stuff that is not in the particular page. So for example, you can add year, and that will divide by year, but if it's on year 2011, you won't see the effect of 12, 13, 14 by proliferation of the marks because they're hidden. But your calculations are still happening individually for 2010, 2011, even though you don't see the marks for them. And here are the shelves that have no effect on LOD. They do change the results because they, for example, filter out data. Your numbers will be different, but they don't change the number of marks and the granularity. Tooltip is a special case. You drag a dimension there, will automatically convert it into an attribute, which is a measure. Hence, it has no effect on the level of detail of your view. So we talked about having dimensions defining the level of detail. Of course, once you define the level of detail using a dimension, all your computations, like average sales in this example, will compute at that level of detail. Let's assume you have store ID in a viz. In this case, average sales will compute average sales per store. But with level of detail expressions, you could do a fancy animation, something like this, and say, even though I have store ID, I actually want my numbers to compute per state. Well, once you do this, it gives you this option. You can compute your average sales within each store to the state they're part of. So you can say this outperforms or underperforms the rest of the state. So that was our first example using the fixed keyword, but there's more than one keyword you can use to write an LOD expression. Fixed, include, and exclude. And I'll dedicate some time on each of them. But let's look at the structure of an LOD expression. An LOD expression has 3 parts. The first one is the keyword. Then we have dimensionality, which is where you specify at what level something should be aggregated. Then you add a colon. And after the colon, you add what we call the aggregate expression, which is the type of aggregation that you want to apply given the dimensionality. In this case, this will give us sum of sales per customer ID. You wrap them in curly braces. That gives us a scoping, so we can tell easily where it starts and where it ends. Because sum of sales is not the only thing you can put in there. You can put more complex expressions. For example, you could put multiple aggregates in there. So you could see the difference between the first date and the last date for the customer, first purchase and the last purchase. You can even put more complex things, endless if blocks, whatever you want. The nice thing about the curly braces is you can see where it started and where it ended. It provides nice scoping around it. So let's talk about fixed as the first example. So I will walk you through some really simple examples. Assume you have these dimensions in the viz, and this is the measure. What are we computing? And we'll answer and go on. So in this case, assume you have a viz that has two dimensions, segment and category. And you wrote this expression, fixed category sum of sales. What does this compute? So category, right? It's fixed. It's absolute. Fixed doesn't care about what else is in the view. It will always compute at the level of detail you specify. So the nice thing about something like fixed is, since it is absolute, it doesn't matter what's in the viz, at any point in time, you know what it's going to compute, right? It doesn't depend on the view, like something like sum of sales. Until you drag this into the viz, you have no idea if it's sum of sales per person, or sum of sales per state, or year. It is defined within the context of the view. So as a result of this, well, we call these measures, so you can't use them as dimensions because they're not defined by themselves. The nice thing about fixed is, again, it's defined, so you can use it in more context, like a dimension. So if you look at sum of sales, the formula, total sales that we looked at, if you go to the context menu, there's no option to convert it to a dimension. That will be under convert to discrete. If you want to create bins on it, you will have no option to create bins. Because, again, it's not defined unless it is in a viz. And all of these things in these menus that you see have to be something that's concretely defined in the data source. But what if you want to do a histogram of something like total customer purchases? Well, you're out of luck unless you use an LOD expression, because sum of sales is a measure and you cannot create bins on it. So let's take that and make it into a fixed customer ID or customer name sum of sales. Now if we go to the context menu, do we have convert to dimension? And we have create bins. You can just click on it, create a bin, and now I can create a visualization like this. And I can see that most of my customers spend less than $5,000 or so, but there are some people who spend about $40,000 on my products. Another common use case is first or last event. You could look at the minimum or maximum dates for a given dimensionality. In this case, we're looking at something that is the sum of quantity of items sold per year. But I might have a question like, I want to understand if my early customers are contributing more to my sales compared to my recent customers. So you want to essentially divide this chart by the first purchase year of the customer. That is an aggregate, but you want to use it as a dimension, so you can slice it. Let's do that with an LOD expression like this. And this is the minimum order date for my customer. And you could see it's automatically listed in the dimensions in the data pane. If you did something like min order date, it will be in measures because its dimensionality is not defined. Now I can drag this in. Now it's a dimension. It wraps it in year. And I can see in my bar chart by the color that my early customers are still the biggest purchasers of my product. My newer customers are not contributing that much. Another common use case for LOD, and I put in tiny print that this applies to all LOD calculations, not just fixed, is overcoming this error. And this is the first suggestion you get from Google. I think this is the most Googled Tableau error message of all time. We type something like, I want to see how many days since the first purchase date. You do min order date, and you get this error. You can't mix aggregates and disaggregates. We can technically say, well, I want to get min order date for customer. In this case, the fixed, I highlighted the curly braces. But you could put any curly brace, any keyword, and all of a sudden that error is gone. Because now Tableau knows at row level what to compare it with, right? So a good way to think about it is, and we'll even see the queries, SQL queries that we're issuing, we treat level of detail calculations as if they're disaggregates. So they're aggregates function that computes something by rolling up your data, but they get joined back into the main table and a SQL statement, so they can be treated like disaggregates. Okay, let's move on to include, where things get a little more interesting after this. So let's take a similar example. You have a viz that has a segment in it, and you're saying include category sum of sales. And this will compute sum of sales per Well, first we'll get what's in the viz, because include takes whatever's in the viz and adds something else. So you have segment and plus category because it's include, so it will compute sum of sales for every combination of segment and category. So there's one interesting thing here, because if your viz only has segment and your calculation has segment and category, you have this mismatch between the viz and the calculation. The good way to think about this is your LOD expressions are separate tables. Somehow they have to be coerced into the main table, that's your view. Let's talk about how Tableau deals with this mismatch. Okay, calculation finer than viz LOD. Let's take the same example, include category sum of sales. And let's add some numbers to make it easier to follow. Here, the shades of the same color are the same segment. So 7 and 3 belong to the same segment, but different category within that segment. And here's our viz. So I have 4 points in my viz. Let's assume a scatter plot or a bar chart. And then my LOD expression returns 6 points. Somehow Tableau will take that 6 and squish it and force it into those 4. And how does that work? So we'll have to roll up to viz LOD using some aggregation. In fact, you'll notice when you drag a level of detail expression into the view, we'll force an aggregation around it. You can change it later, but it has to be aggregate. So in this case, let's say we did an average. You chose to do an average. And what's going to happen is we'll take 7 and 3, add them up, divide by 2, you get 5 for the large blue dot, 2 plus 0, divide by 2, you get 1. And 6 and 8 won't change because there's no multiple categories for a given segment. They will be identically moved. Behind the scenes, more visually, this is essentially what we're doing. So your LOD expression is the topmost one. It returns a value for consumer and category combinations. That is, in this case, 9 different values. The view has only consumer, corporate, and home office. So what it does is it takes everything in those brackets and averages them in this example, and you get 1 value for consumer, because that's 1 mark you have in the viz. And if you like SQL, maybe you do, I don't know. This is what it looks like. So essentially, every LOD expression is a subquery that gets joined into the main table. The viz is a query itself. And I highlighted some important parts. You could see we have a query that's happening at segment category level. That's your LOD expression. We compute sum of sales as sales per segment category. And then the second calculation that gets interjoined takes the average of that, and that you could see in green, and groups by segment. That's a roll-up from category segment combinations to all the way up to segment. So a good example for include is when you want to bring in dimensions that you don't necessarily want to show in Tableau or bring the data into Tableau for. Let's say you're looking in this case, annual sales. It's like $700,000 or so. But you want to understand something like, oh, what is my average spending per customer for a given year? So you can write a calculation like this. Since this is an include, what it's going to do is it will take year, then it will add customer to that, because it's an include, and sum of sales will be per customer year, right? But the next thing you want to do is you want to take the average of that, because you don't want to do another sum, but we'll, by default, wrap a sum around it. So at this point, the results don't look different at all. You still have 700,000 K, because sum of sums is the same as sum of everything. So you'll convert that to an average from the context menu. And now what you're seeing is your customers were spending about $800, and then it went down to $750. I think that's around the time economic crisis hit, which is cool that Superstore database actually has that built into it. And then it starts recovering. Now, exclude. It's kind of easy to guess what it does given we talked about include, so, but let's still work through an example. Let's assume you have 2 dimensions, segment and category, in your viz, and you write the calculation exclude category, average sales. And what this will do is it will take the stuff in the viz, segment and category, and it will exclude category. So we'll cancel that out. This calculation will give you average sales per segment. So this is the opposite case of include. Now you have a calculation that's coarser than the viz LOD. Now Tableau has to do the opposite of, well, I have 4 marks, 4 points in my mini table, that's the exclude calc, but I have more marks in my view. Somehow I have to mitigate this take care of this gap. So you have exclude category, as in our example earlier, segment is the level of detail of the calc, and viz is finer. The same thing, I'll put the numbers in, and we'll see what it does. So Tableau will take 10, and it will replicate to all the shades of blue. Right? Those are the different categories within the same segment. The blue segment has 2 categories, different shades of blue. So 10 goes 10, 10 down there. 2 will replicate to shades of green, and 6 and 8, no change because it's a one-to-one mapping. There was only one category in that segment. And behind the scenes, this is what it is doing. You have the expression that gives you the total sales per segment, consumer, corporate, home office, and your viz has a lot more marks that as you can see on the lower left corner. And it is taking the value for the entire segment and replicating for all of the categories within that segment. Right? Consumer has 1,161,401, and furniture, office supplies, technology, they happen to be within that segment, so they all get the same value. And this is what the SQL query looks like. Again, LOD expression is interjoined into the main table, and you could see I'm just doing a group by segment, which is the level of detail of my LOD expression. Then it gets joined back into the table that contains category and segment, hence replicating to all the categories within that segment. So a common application for exclude is something like percent of total. Because you created this mismatch between something, you created something much coarser level, probably a category that covers all the finer grain data. In this case, I have a category and subcategory. I'm doing an exclude on subcategory, so it will give me the sum of sales within the entire category, right? And if I do a divide by, then I'll give me the ratio of a given subcategory to the rest of the compared to the entire category. And one cool thing about exclude is Tableau knows that it's replicating. So I added totals. You see, it's the same value. And if I add row totals, it's the sum of only one of those bars. Even though there's even more of them, it doesn't add up to this gigantic bar. Because Tableau knows it's the same value repeating. It's not going to add it up multiple times. So when you're applying exclude, you can be comfortable about what Tableau is going to do because it knows it's replicating. It will be smart about all the extra applications you can do after that. So this is not a really good application of it, but it's a question that comes up often. So let's say you did include nothing or exclude nothing. Let's talk about what Tableau will do if you do that. The same viz, let's say this time you have state and county, you did include nothing. If you include nothing to state and county, you will get sum of sales for each county, no difference. Same thing with exclude gap, sum of sales, you will still get the same as with LOD, there's no difference. But for fixed, there's a slight difference. So if you do fixed nothing, since there's nothing to inherit from the viz, you're adding nothing to nothing, which means Tableau will assume you want one value for the entire table. It's as if you drag the measure into the view, there are no dimensions, you get just one value. I'm sure everyone hit this the first time they downloaded Tableau. It's like, what happened to all my data? There's only one value in this viz. So that's what it does. It assumes that you want the overall minimum maximum for the entire table. And there's a shorthand version of writing this. Instead of putting fixed nothing sum of sales, you can just put the curly braces and we'll take that as fixed nothing sum of sales. So far we talked about all of these examples where your LOD expression somehow has an overlapping LOD with the viz. Like there was segment category, their calculation could be segment, so there's an overlap, there's an explicit mapping join dimensionality. But there are cases where you can actually write things that are completely disjoint. In this case, assume you have a viz that has state in it, and you're writing this expression, fixed customer sum of sales, and dragging to that viz. There's no overlap between the level of detail of the calculation and the rest of the viz. But nice thing is, Tableau already knows there's a relationship because in the underlying table there's a relationship. Each of those customers live in a state or they purchased in that state, so we have that mapping. What Tableau does, it takes advantage of this information to do the join for you. And this is kind of an interesting case. I was trying to justify an example of this to show what it does. Let's assume you have a customer in this case John, and he travels a lot. He goes to one city, buys, I don't know, chewing gum, goes to the next city, gets a can of Coke, and you're trying to compute this, like, what's the average spending for my customers? And he's skewing all your numbers because he's just buying, like, spending $1 here and $1 there. And your solution to this problem of skew is you want to add up all of his spending, regardless of where he spent it, and then replicate it to the state he lives in, or across all the states, so the numbers are not skewed. Because what you're trying to do is understand, your resident customers for your grocery store and how much money they spend. So you can actually force this with this really simple calculation, and it will do something crazy behind the scenes, which is this. So first, it will compute the sum of sales for each customers. In this case, John spent $115 across multiple states, because you don't have state in the level of detailed expression. It's not doing it for combinations of states and customers. It's just by the customer name. And then, since we have to do some mapping, what we do is we have this intermediate table that we join with that replicates John's spending to all the states he visited. That's his total spending replicated across multiple states. And then we have to come to the viz.LOD somehow, which only has 3 marks for 3 states. Then it does an aggregation after that. So with such a simple calculation, you have this multiple levels of joins happening in the database. We first aggregate, then replicate, and then aggregate again, which is pretty cool. OK, so another crucial part of level of detail expressions is the filter sequence. And it allows you to do a lot of cool tricks with level of detail expressions. So it's good to understand how filters work in Tableau and how you can take advantage of it. It also impacts whether you choose between a table calc and an LOD calc for doing the same task. So here are the different kinds of filters you can do in Tableau. I put different colors. Extract filters is orange because if you don't have an extract, you don't have an extract filter. So that's specific to that case. You have data source filters, context filters, dimension filters, and measure filters. Context filters are actually dimension and measure filters, but we essentially lifted that up and put it in a different category that happens earlier. And we have some optimizations. It's always there in some sort of a temp table or a subquery format. So it's handled differently, but the idea is you can take a dimension filter and promote it to a context filter. And then we have table calc filters. So first of all, what's a dimension filter? If you're SQL friendly, a dimension filter is a where clause in SQL. It happens before the aggregations happen. So let's say you're trying to compute sales per customer, and you wanted to filter out a dimension, which is a type, let's say, all the beverage purchases. It's a dimension. You drag the dimension in the view and say, I want to exclude beverages. That exclusion happens before we compute sum of sales. So all of your sum of sales values changed because we filtered out all the beverage sales while we're computing sum of sales. That's a dimension filter. A measure filter is what will be a having clause in SQL that happens after the aggregations. So you could say, I want to keep customers who spend a minimum of $100. Now we computed the sum of sales of 100. Then you're filtering out customers that meet that criteria or don't meet that criteria. Since the amount that you're filtering out on is a measure, like sum of sales of a minimum $100, it's called a measure filter. And again, since you computed the aggregate after dimension filters happen, it's the second from the bottom. And then we have table calc filters, which is again somewhat interesting because it hides the marks. It's similar to clicking on a mark and say hide in Tableau. They're still there in Tableau, you just can't see them. The only thing they will affect is reference lines, trend lines, box plots, all the overlays, things that we're doing. So now that we talked about what dimension and measure filters are, where does fixed, include, exclude fit in this graph? So fixed happens before dimension filters. And the reason for that is you can use fixed as a dimension. So it doesn't make sense for it to apply after dimension filters. Include, exclude, on the other hand, again, they are dependent on the context of the viz. They're not defined outside, so you cannot use them as dimensions. As a result of that, they act like measures. They apply as measure filters, and measure filters happen after them. One way to think about it is, look, if you look at it, table calcs happen before table calc filters because you have to compute it first before you can use it as a filter, right? So there's this logic of dimension, dimension filter, measure, measure filter, table calc filter. Okay, so I see some faces like, okay, that's where you lost me, but if you play with it, it will make a lot more sense. So given this, you can take advantage of the situation of the fixed in this diagram to do a lot of cool tricks. Let's look at a few of them. So in this case, I have fixed category sum of sales. And I have another calculation that has the functional equivalent of that, exclude subcategory. Both of these are category sum of sales. Let me filter and see the numbers match at this point, given there are no filters. And as I filter, the right-hand side, fixed, is not affected by the filters. And the left-hand side does something that doesn't make any sense. In fact, I filter just down the accessories. It will tell me accessories is 100% of accessories, which is totally useless information, right? The nice thing is, with fixed, you could say, I don't want my total to change because of my filters. If I'm computing a percent of total and I want to hide 5 states because, I don't know, for some reason I don't want to include them in my view, then they should not be excluded from my total. They're still there in the total, but they're excluded in the view itself. This way you can achieve that scenario without getting into this situation of 100% of itself. Another use case is here I have fixed category sum of sales and sum of sales. This is a dual axis chart. You can do what people call a proportional brushing effect. It looks like I'm highlighting portions of the bar as I select, because I have two calcs that are two bars that are overlapping. One is affected by the filter, the other is not affected by the filter. Right? So there are pretty cool things you can do with this by just taking advantage of the filter order. And again, if we go back, if you really want fixed to be affected by the filters, since we talked about being able to take a dimension filter and promoting it to context, you just right-click on it in the filter shelf, say promote to context. Now your fixed calculations are also affected by the filters. Okay, let's go back. Okay, now more fun stuff. Once you do one level of aggregation, you could do more. We don't have any limits on how many layers of nesting you could do. You can compute a sum of something, then average it across something else, and do a maximum of that and do something else. We don't have any limits. Probably the limit is your database admin screaming at you because you have so many inner joins and everything is slowing down. Of course, when you do nesting, there's this concept of inheritance. And inheritance works in two ways. One is inheritance of dimensionality. The other is inheritance of filters. And the way it works is very similar to how things work in real life. The children inherit from their parents. So in this case, I have a nested calculation that has fixed and include. And it's the same as the bottom one. And the reason for that is a fixed will push, so include inherits the dimensionality from the outer context. It could be the viz, or it could be the encapsulating calculation, right? It takes the viz and adds something. It takes the outer calculation and adds something. So we'll take inherit state from the outer calculation and compute at state and customer level. It also inherits the filter, so it will act like a fixed calculation. As a result, it's the same as writing fixed state customer sum of sales. So one question I get when I talk about LOD expression is a lot of people don't like table calcs because there's lots of settings, addressing and partitioning, and it often gets confusing. And there are certain cases where you can do what you would do with table calcs before LOD calcs were introduced using table calcs. But for example, you could do window sum, window average, or totals using table calcs. Now you could do the same with LOD expressions. So a lot of people are, yeah, I don't have to use table calcs anymore. Well, sometimes maybe that applies, but sometimes you still may want to use table calculations. So one reason is table calcs are really fast if you have all the data in your view, which is pretty common if you have some exclude kind of a calc, because you have all the bars, you're trying to do percent of total. You can decide to run that query, issue another query to the database to do it with a join, or you could say all the data I need is in Tableau, I'll just write a table calc. In some cases, it'll be faster to use a table calc compared to an LOD expression. But there are cases like the include example I showed. You could have this bar chart that only has 4 marks in it, years. But you want to see what's my average transaction in every year. Well, you can have 10 billion transactions in database. Do you want to bring all that into Tableau and do a percentage calculation in Tableau? That would be super slow. Then that's the kind of thing you want to do in a database, because it will roll up, it will compute the average for transaction within a year, and then just give you the 4 marks. It will be much faster that way. So it's more of a apply it on a case-by-case basis. You can also try to imagine what I just showed about the filter order. Table calcs happen at the very end of the pipeline. You may have other things that get filtered out in the process with measure filters. If you want to apply the same thing using an exclude calc, well, it's not impacted by the measure filters. That means you have to use it as a table calc. So now that we talked about all the cool things you can do, the best part is the stuff that you can't do. So I used to start with a list of databases that we support LOD calculations with, but the list is changing so fast, so I decided to exclude it because before this video gets published, probably it will be out of date. So instead, I will say it works with extracts and it works with most relational databases because we write SQL. It won't work with cubes. And you can look at our documentation to understand what databases support it. It's close to everything, but there are certain databases we're having issues with the optimizations they do. So the results become unpredictable for complex queries, so we decided to not support them. We don't support it on generic ODBC. JET has some limitations. We can't do a full outer join. That's why it's not supported there. But generally, if you're using something like Oracle, MySQL, Postgres, SQL Server, BigQuery, there's a large list that we support. So these won't be materialized in Tableau extracts. And let me clarify that because sometimes people take this as it doesn't work with extracts. It does work with extracts, but extracts have this option. You can right-click on it and say optimize. And what it will do is if you have a complex calculation, it will compute the value and store the value so it doesn't have to recompute. It's stored in the extract. So it'll be faster to open. We do that for row-level calculations for performance reasons. And one common question is people will say, oh, fixed calculation, you already know at what level it happens. So you can technically persist this when you optimize it. The problem is Tableau extracts currently don't know it's an aggregate. So if you stored the value, next time you aggregate it, we won't be able to do this trick I showed you, like totals are smart. Oh, it knows it's being replicated. It won't count them twice. The extract will actually double count them. If you have someone's, you join with a table that has one row for the kids of someone, then you compute their salary. Well, since you joined, the salary replicated for as many kids as they have. And if we store that in the extract, next time you compute their salary, if they have 4 kids, they have 4 times the salary. So to avoid that problem, we choose not to materialize them at this point in time, but we'll improve that. So I crossed a bunch of things here, and the reason for that is last year I gave the same talk, and these were not supported. To show you that we're making progress, to make things better every release, I just tried to cross them out. Now you can use sets, combined fields, bins, groups, parameters as arguments to LOD expressions as dimensionality, which you couldn't do before. You still can't use measures or table calcs in there. You can put formulas in there. In the past, you could just name a field. Now we can write a formula as well as LOD expression, as dimensionality of an LOD expression. Again, same thing I just mentioned, you can't use table calculations. Include, exclude don't become dimensions, which we talked about. And then here's the limitations about blending. You can't mix parts of an LOD expression from different data sources. You can't have a dimensionality from one source, measure from another, aggregate from another source, or one dimension from one source, another dimension from another source. And the last one is a bit confusing, so I'll show you an example. It works really well with data blending 1, but doesn't work with data blending 2. So the question is, what the heck is data blending 2? So in this case, here's an example. I have an LOD calc coming from a secondary. You can see that with the orange check mark next to it. And this is what it looks like, fixed ship model region to prove that it is working. So in this case, what you're seeing is I have ship mode and region in my view. I also have ship mode and region as linked fields. You can see the links in orange. If I add one more, as you can see, I'll just check that. Now I have 2 dimensions in my view, but I'm linked on 3 views. By doing this, you went from data blending 1 to data blending 2. And now you get this error message that says cannot blend the secondary blah, 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 which doesn't tell you much, but that's what's happening. And if you use data blending 2, we have the same error message if you use something like median or count distinct. It's the same error message. It will work with blending as long as any dimension you have in the view is checked and no more in the linked fields list. Okay, so here's an example. If you just put pure sum of sales, it will have no errors. It's erroring out because we don't support data blending 2 and level of detail expressions. So that's the end of my content. I'll stick around for questions. I have one more repeat tomorrow. And we have a few other sessions that are relevant, that are hands-on. And we also, again, we have examples of real-world problems that you can solve with them. Please complete the survey so I know how well or how terribly I did and make it better next year. Thank you.